So today we're gonna have a lab, or at least a demo, and it's gonna look like this. And so I'm gonna draw out kind of what it's gonna look like to begin with. So I'm gonna go with red for the force, and so down here we have the force versus time. This is time on this axis, and this is force right here. And so at the beginning there is zero force being applied. So you're just kind of like da 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 da, and you're not really doing anything. And then what you can do is, if you've watched the video, you know what's going to happen is you're going to pull, and as you pull, it's going to give kind of a mountainous kind of like this, and then you're going to stop pulling, right? And what's going to happen is, as a result, and I'll show this in green, as a result, your velocity of your cart, and your cart's just like do 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 do, sitting here doing nothing, right? Zero velocity. And so then all of a sudden it's going to go whoa, and it's going to increase its velocity to a certain point right there. Okay, and then you're going to let go. And then when you let go, the cart is going to slowly slow down, and like this, slowing down. Okay, and that's what it's going to look like on here, and that's what's kind of happening. So what do we have happening then? So right here, this force it has an area, and the area of this force is called the impulse. And impulse is equal to force times time. And so this right here, this is the area. And that area is equal to your impulse. And since your impulse is equal to force times time, then later on we can do some math and we can kind of figure these things out. The exact numbers and what the exact numbers mean. And so here, your velocity is 0 meters per second. And then you have a change in velocity, a delta V. And you end up going this fast right there. And that fast right there is the maximum velocity, which is 0.47 meters per second. And so what we have is impulse causes a change in momentum. So impulse causes a change in momentum. So this is the cause, which is impulse, and it causes here to delta P. So we're going to start off with that and look at a couple of these numbers. So the first thing is that the total impulse here is going to be equal to 0.5 Newton seconds. And if you look up here, we have a total delta P. Oh, by the way, the cart itself is going to have a mass of about 1 kilogram. And that's important because it makes our math very easy. So the cart with the weight in it is a mass of 1 kilogram. So since impulse is equal to change in momentum, then we can write this a whole bunch of different ways. But impulse is 0.5 Newton seconds. And the change in momentum, actually, in this case, is m delta v. And since the m is 1, and the delta v is 0 to 0.47, then 1 times 0.47 is going to give us, and I could write it out, but I mean it's just 1 times 0.47 is 1 times 0.47 is 0.47 kilogram meter per second. And so does that make sense? Does 0.5 equal does 0.5 equal 0.47? And the thing about this is there's always going to be some friction involved. And so anytime you have friction involved, there's a chance that you're not going to have these two numbers the same. So they are close, but the reason they are not exact is because of friction, and friction is due to rough surfaces, etc., and so forth. And so this is the story of the lab as we have it so far, and I will come back and probably give some more details in a little bit.